Hello everyone, welcome to the second video for the series of 7 QC tools. Here in this video we are going to learn about the cause and effect diagram or the fishbone diagram, or it is also called as the Ishikawa diagram. In this video we are going to learn about what is this cause and effect diagram or the fishbone diagram, why is it called as the fishbone diagram or the Ishikawa diagram or the cause and effect diagram. We are also going to learn about what the structure of the diagram consists of. We are also going to learn when to use this fishbone diagram. We are going to learn about the step-by-step process on how to create a fishbone diagram. We are also going to take a case study on the cause and effect diagram with an example so that you can have insights on how to use this tool in a real world scenario. Without any further delay, let us go into the video. What is cause and effect diagram or the fishbone diagram? This tool is a visual tool which is used to systematically identify and present what all possible causes, not a specific cause, not a finalized cause, but to present all possible causes, which means the cause may be or may not be final. All the possible causes of a specific problem. This tool was developed by Kaoru Ishikawa in the 1960s. Hence, the tool is also called as the Ishikawa diagram. Kaoru Ishikawa was considered as a pioneer in the quality management. This tool also symbolizes a skeleton of a fish. Hence, the name fishbone diagram was given. Here in this tool you can see two parts. The first part is the cause part, where we will list down all the possible root causes, all the possible causes during brainstorming. And the second part is the effect, which will have the problem, the details of the problem what we are having or facing. Hence, the tool is also called as cause and effect diagram. This fishbone diagram is used to identify and categorize the potential causes or the possible causes of problems what we are facing, by to identify the root cause. It's like a brainstorming map that helps us visualize why a problem is happening. Next, we are going to learn about the structure of the tool or the cause and effect diagram. The structure of the cause and effect diagram is similar to a fish bone, consisting of the head, the big bones and the smaller bones. The elements of the diagram consist of the head of the fish, which is the problem statement or the effect. The problem statement considers or consists of the details of the problems what we are facing. The major bones consists of the categories of the causes, commonly known as the 6 M's, which is man, material, machine, method, measurement and mother nature. In the smaller bones, what we are seeing here, in this we are going to list out all the sub causes or the detailed causes or the probable causes during the brainstorming sessions with the cross-functional team or the relevant process owners. Now we are going to see on when to use this fishbone diagram. This will be ideal to be used when we are investigating for the root causes of recurring problems such as the customer complaints, production rejections, the in-house rejections or reworks, etc. This will also be ideal to be used when we are conducting a brainstorming session. Meeting with the brainstorming means the meetings what we hold with the cross-functional team or CFT or the applicable process owners, that is with a team, to list out all the possible root causes. This will be ideal to be used when we are conducting a brainstorming session with the team to list out all the possible root causes. The third point is that this will be ideal to be used when we are improving or analyzing the process performance. Process performance analysis means the examining how well a process is working. For example, a manufacturing line is producing too many defective parts. You use the fishbone diagram to analyze why. Is it due to the wrong materials or the wrong raw materials what we are using? Is it because of unskilled workers? Is it because the measurement instruments are not calibrated? Here you can see the raw material comes under the material of 6M. The unskilled workers comes under man of 6M. This measurement instrument also comes under the method, or it can also come under the measurement of the 6M. Here the fishbone diagram helps you analyze all the possible causes of the poor performance. Here the problem what you are facing is the defective parts. For these defective parts, we are doing a brainstorming session with the team to list out all the possible root causes. We listed down all the possible root causes, like is it because of wrong materials what we are using? Is it because of unskilled workers? Is it because measurement instruments? These are the possible root causes what we are listing down by using the fishbone diagram. Hence, this fishbone diagram, it is the perfect tool for the root cause analysis. Now we are going to look into the steps on how to create a fishbone diagram. The step-by-step process on creating the fishbone diagram includes: first, the defining the problem clearly. Means clearly define the problem what you are facing by using the 5W and 1H method. I am going to explain this method in the upcoming slide. Second step is draw the diagram or the fishbone diagram with a horizontal arrow pointing to the effect. The horizontal arrow of the cause pointing to the effect or the problem what we are facing. The third step is identify main categories, 6Ms or tailored categories. Means based on the problem what we are facing, the possible root causes during the brainstorming session may come under all 6Ms, like man, material, machine, method, mother nature or measurement. Or it may also come under only 3M or 4M, like man, material, method and measurement, or man, method, measurement or mother nature, like that. Depending upon the nature of the problem what we are facing, the probable causes will come under any of the 6M or all the 6Ms. The fourth step is brainstorm all the possible causes and draw them as branches. The branches here which come considered as the smaller bones, which I shown you in the diagram. The fifth and the final step is analyze these causes to identify the most likely root causes. To identify the most likely root cause, we need to list down all the possible root causes which we have identified using the fishbone diagram, and then classifying all the probable root causes into significant and insignificant. We need to validate all the possible causes which we have listed down by using the fishbone diagram. That is how the fishbone diagram helps in the root cause analysis. Here in this slide, we are going to look into a case study to better understand on how to use this fishbone diagram effectively for the root cause analysis. The case study what I have taken is the higher rejection rate of the machined components. The step 1 here on how to effectively use the fishbone diagram is to define the problem clearly. Means clearly define the problem by using 5W and 1H. This 5W and 1H stands for what, where, when, who, why and how. The problem statement what we are considering today is for this case study is the high rejection rate observed in the CNC machined components during final inspection. Here by using 5W1H method we are defining or clearly explaining the problems what we are facing. The first question is what is the problem? The answer would be the high rejection rate is in the final inspection. That is the problem what we are facing. The second question is where is it occurring? It is asking for the location. It is occurring at the CNC machining section or the final dimensional inspection stage. The third question is when is it occurring? It is asking for the timeline. We are facing this problem frequently in the past 2 weeks. The fourth question is who is involved? Here the CNC operators and the machining section and the quality inspectors who is inspecting those parts. These are the persons who was involved. Why is it a problem? It is asking why this high rejection rate is a problem. It is asking. It is a problem because it is causing delivery delays and also rework. It is also affecting the customer satisfaction. That is why this is a problem. How was it identified? That is the last question. It was identified through the in-process inspection, and we also have a similar customer complaints. So by defining the problem what we are facing by using 5W1H, all the members who are participating in the brainstorming session will have a clear understanding so that we can arrive at probable causes or possible causes more effectively. The second step for this case study is draw the diagram with a horizontal arrow pointing to the effect. The second step is drawing this line, the horizontal line pointing to the effect, which is the problem what we are facing, which is the high rejection rate of machine components. The third step is identifying main categories, which are the 6 M's. Here in this case study I have taken all the 6 M's, which is man, material, machine, method, measurement and the mother nature. The step 4 is brainstorm possible causes and draw them as branches. For this case study, for each of these main categories, by doing the brainstorming session or discussion meeting with the cross-functional team or the process owners which are relevant to this problem what we are facing, we have identified all the probable causes under each categories and we have entered them in the branch section of each category. For example, if you take the category of man, operator lacks proper training. that would be a probable cause for the higher rejection rates. Or the incorrect tool selection by the operator, that would be also a probable cause. In the machine, if you take the CNC machine backlash, that would be also a probable cause. The coolant system not working properly, that is also a probable cause. Like this, by doing brainstorming session, we will come to know all the probable causes or the possible causes which will affect, which will provide us this final problem, that is the high rejection rate of the machine components. Now the fifth step is analyzing the probable causes to identify the most likely root cause. Means we need to validate, list down all the probable causes which is identified by using the brainstorming session. We need to validate each of these probable causes and we need to classify all the probable causes as significant and insignificant. When we validate and categorize them as significant and insignificant, we will do the YY analysis for only the significant probable causes. We will arrive at root causes for these significant probable causes among these. Then for those significant causes, we will provide correction, corrective action and the preventive action also. Then we will go into effectiveness. Then we will close this root cause analysis. That is how it's done. That is how the fishbone diagram helps us to do the root cause analysis. Here in this slide, we are going to learn about the validation of the probable root cause. Here in this table, I have listed down all the probable causes which we have identified during the brainstorming session using the fishbone diagram. I have also listed down all the categories under which these probable causes are identified. In this column, I have listed down all the validation methods which I have used to validate these probable causes to classify them as significant or insignificant. The first probable cause is the operator lacks proper training. Here the validation method which I have considered is the checking training records or the logs. Checking or conducting skill matrix evaluation. I have observed task execution by using a checklist. Here by conducting skill matrix evaluation for both the people which are involved, which is the final inspector and the machine operator. If I find any gaps in their skill matrix which is required for their job, then I can consider this probable cause as a significant cause. But consider this probable cause, that is the fatigue due to overtime. Here I have considered the validation method reviewing of the shift or overtime logs, interviewing the operators, then correlating defects with the extended shift hours. While correlating the shift time with the defects, if there is a positive correlation, then I would have considered the probable cause as a significant cause. But since I haven't found any correlation between the overtime and the defects, it is considered as the insignificant. Now, this is how the validation methods are used to classify all the probable causes as significant and insignificant. For these significant causes, we will do the YY analysis to arrive at root causes. Then we will provide correction, corrective action, preventive action, effectiveness evaluation over a time period. Then the root cause analysis is finalized for the problem faced. This is how the fishbone diagram is used to arrive at the probable causes, which is very helpful to arrive the root cause of the problem what we are facing. Thank you for watching the video.